So here are the contents and what to expect from this session. We're going to talk about MeshWorks pre and post processors and some key differentiators. So here are the contents and what to expect from this session. We're going to talk about MeshWorks pre and post processors and some key differentiators. And we're going to discuss what to expect from this particular webinar. So we're going to quickly touch on MeshWorks and what is MeshWorks. MeshWorks is a proprietary CAD and CAD platform tool that gives the users high productivity in CAD model building, that helps the integration of MDO optimization, catering to very different industries such as your aerospace, automotive, biomedical, shipping, just to name a few. So MeshWorks so far was basically known as the CAD Morphing module. That also had some design enablers that helped out with some of your optimization tuning for your structure models. Now MeshWorks is complete pre and post processor, and you can see where we added a bunch of different new modules like the CAD integration, process automation tools, and also some of the post-processing functionality that you see in other different softwares. So now MeshWorks is a complete integrated CAD platform. So what does MeshWorks do? One of the things that MeshWorks does is it rapidly converts FE and CFD models to intelligent parametric CAD models, enabling fast design iterations. It also helps in the reduction of CAD model building, and it also has a comprehensive FE and CFD for pre and post processing with powerful tools for your CAD cleanups and all your meshing. So here we're going to discuss some of the key differentiators in regards to MeshWorks compared to other tools. The first thing is the parametric modeling. MeshWorks is a parametric modeler, meaning that if you do the meshing inside of MeshWorks, your models become automatically parametric. The next pillar is MeshWorks is an integrated modeler, meaning that you can take one CAD database and you can generate multiple attribute models. This means that you can click a button and create all your NASTRAN models, having all your NASTRAN connections. And you can also click a button to generate your abacus model, having all your abacus bolt connections along with the context. MeshWorks is also an automated modeler, meaning that it can take very, very tedious workflows and processes, condense them down to very minimal inputs, and provide a 2x to 10x time savings in terms of your workflows. MeshWorks is also an associative modeler. This means that basically once you do the meshing inside of MeshWorks, and if your CAD undergoes any kind of changes, we can basically take those changes and locally integrate those changes in MeshWorks just within a click of a couple of buttons. So what to expect from this session? The MeshWorks application, we're going to show you how we have some tools in regards to the skin mesh for the exterior flow for vehicle skin models. We're going to show you some tools for the skin models for interior flow, such as your HVAC and your duct systems. We're also going to show you some nice tools in order to show you how to get the wet surfaces out of your full assembly models. Then we're going to show you how MeshWorks is an auto parameterization when you do the MeshWorks meshing using the batch meshing process. And also we're going to show you some different morphing scenarios on your circuit boards along with your CAD morphing as it relates to your aerothermal. And also here we're just basically showing you a demonstration or a highlight of how we're going to address some of those different things. So I'm going to turn it over to Sridhar, so he can start giving you guys an idea of how we're going to do the meshing on some of your exterior body styling.
Thanks, Ray. Shirin, can you make me a presenter? Hello all, my first demo is on meshing of the aerodynamic external surfaces for aerodynamics of the car. And here I'm going to use a manual process for that.
So here what we're going to show you is, we're going to show you the manual process. Typically, every solver and preprocessor has different tools in order to do the meshing. We're going to quickly show you how we would do the manual meshing using MeshWorks, and then we're going to show you some different parameters that you can create on the fly.
So for doing the meshing, I'm going to the basic measure here, and in basic measure, I'm going to use a measure option here. And a user have to do only small operations to create the external mesh for this component. The first one is like the selection of the type of mesh. A user have to select the element type. So right now I'm going to select my element type as tria, and we have different methods for the selection. One is R-tria or union jack or R-tria max. So I'm going to use R-tria max. And in the mesh process, you have different methods like flow mesher or map mesh or auto mesh. So generally for meshing an external surface for the CFD analysis, we need a better mesh flow. So for that I'm going to use a flow mesher. And once I select all my options, a user have to just input the mesh quality, which is the min, max, and the average element size. So once the user specifies this, just we need to select the surface and just say preview and execute. So generally to generate this kind of mesh, it takes a couple of minutes. So in interest of time, I want to demonstrate you the existing mesh which is generated using the same process.
So now the mesh has already been generated, and what Sridhar is going to show you is how we can do the parameterization manually. We're going to show you how the automatic parameterization is going to happen later in the later demo.
So this is the mesh which is generated out of MeshWorks using the manual process. So if you see like the feature capturing and the element quality is very nicely captured all the features. So this is about the manual meshing. Now I'm going to move on to the next demo, which is auto parameterization, parameterization of the external surface. So for that I'm going to morphing, parameterization. So I'm going to set up the morph set here, and I'm going to use a field-based morphing. So the first step, I need to select the control nodes. So I'm going to select by nodes by path option here. Now the next step is defining the deformable nodes. So for that I'm going to define using by adjacent layers, and I'm giving the adjacent layers to be like 20. And once I select the deformable layers, I need to select the fixed zone. So if you see like using the auto fixed zone, MeshWorks automatically defines the adjacent layers of the deformable nodes as a fixed nodes, and I'll just say create. So MeshWorks automatically creates a morph set. So once the morph set is created, I need to link the morph set which is created to do the parametrical change. So once you click on link, MeshWorks automatically links the created morph set, which shows what are the control nodes and deformable nodes, fixed nodes, which are linked to the morph set. Then a user can either create a parameter using the parameterization tab, or a user can go for tools and do a one-time execution. So right now I'm going to use the tools, translate, and I'm going to select all my control nodes, manipulate on screen, and here I want to reduce the drag coefficient of the external aerodynamics, so that which improves the fuel consumption. So for that I want to move the tail lamp in the X direction, specify the direction, and manipulate on screen. So if you see like in very less time, with very minimal steps, I have created a parameter and I have linked and created the shape changes. So using this, a user can change the shape changes and improve the performance of the drag and lift coefficients.
And using the X direction is only one way. You clearly see that we have a bunch of different translation types. We can use individual directions. We can also go about a vector if need be. And here you can see that we're clicking on the Z direction in this particular situation. So we have very different ways in order to manipulate this part. And we wanted to basically show you how easy it is to create such a parameter using the manual method.
With this, now I want to move on to the next demo, which is internal surfaces meshing using the interactive batch mesher. So this is a CAD component, which is a hatchback model, and I want to do the mesh for the internal ducts so that I can study the internal flow. So for that, I have organized the internal surfaces into different PID. Now I want to isolate only the internal surface. Click on basic mesh, and it will take me to the interactive batch mesher here. And if you go to the interactive batch mesher, the user have to select only minimal steps. One is the CAD surface, which will be my air duct, and the second step is I need to specify the mesh templates. So I'm going to show you what the template has. Just before that, I just want to execute this mesher. So I'm going to select a 3 mm mesh and just say execute. So it's going to take a couple of minutes. In interest of time, I'll move on to the next window so that I can show what exactly the meshing template has. So if you see the mesh control panel here, it have all the meshing parameters. For example, like if you see the general meshing parameters, a user can select the mesh type, let it be tri-arc, chord, or mixed, and a user can specify the element size, min element size, max, and average element size. And when it comes to the CFD models, as we don't have much kind of holes and fillet lines, a user can go directly for the fillets, and he can specify the number of elements on the fillet based on the range and element length. So like this, a user can create their own template, or we also have a template which is stored in the installation drive, which you can see below. And similarly, the quality control parameters, which a user can use it, and also mesh process control parameters. So these are the parameters which a template has, which MeshWorks is taking and generating the mesh. So if you see, like the mesh have been generated for the selected model. I'll just quickly click on return, auto color. So if you see the mesh, like MeshWorks have very nicely organized all the different features into different PIDs, which becomes a parametric model actually. So if you see, like the feature capturing have been taken care very nicely, and the mesh flow is very nice, without much of the rotated elements and rotated features. So once the meshing is done, the model becomes parametric. So now I'm going to demonstrate you the auto parameterization of this component. For that, I'm going to the morpher. Here I'm going to use the auto parameterization of casting. So we have created this panel based on the user's usage, like based on the much interested parameters. For example, like we have a fillet radius change, tube diameter, rib height, and rib thickness as a different parameters. In the CFD mindset, like I want to increase and decrease the fillet radius so that my flow, the internal flow, will be optimized. So for that, I'm going to select a fillet so that I can create it as a parameter. So for that, I'm going to select this region. So I'm going to select this region here.
And you see how he's selecting, he's automatically selecting the elements by surface. So you can see that the user doesn't have to select the elements, but he's nicely selecting the elements by surface. And this will automatically allow the user to go ahead and create a parameter using plus or minus 20%.
And just click on execute. So once you click on execute, MeshWorks have given a message like it is done. So and also one good thing with this parameter creation is like it gives a graphical representation which shows the minimum what is the baseline radius, which is 8, and a user can review the parameters by linking it. So when you review the parameters also, the graphical representations change accordingly. So this helps in optimizing the models for any of the flow analysis, and it saves a lot of time, and a user doesn't need any expertise in doing this parameter creation and morph set creation. So this is all about the auto parameterization of components. Now I'll move on to the next demo, which is wet surface isolation. So for that I'm going to import a new model. So if you see, like I have a component on my screen for which I want to extract the wet surfaces. Wet surfaces are nothing but the inner surfaces where the liquid or air flows or contact with the air or liquid. So if you see the components, like right now it is organized into a single PID, and now I want to isolate all the internal surfaces, which becomes my wet surfaces. So for that I'm going to use the wet surface isolation method, which is in CAD tool. And the minimal inputs which we give is I need to select this all my surfaces, and the user have to specify the resolution and tolerance for the cavity generation. So it is based on the size and the complexity of the CAD. Right now I'm going with the 10 as my resolution, and just say find inner cavity. So once the user clicks on find inner cavity, MeshWorks automatically detects the inner cavity, and it will create a hexa elements inside that, which will be the input to the next step. So once the inner cavity have been generated, a user have to select the generated FE and just say isolate. So once the user clicks on isolate, MeshWorks automatically finds based on the cavity which is generated using MeshWorks, it will try to find the tolerance between the inner surfaces and the cavity, and it will try to organize all the inner surfaces into different PID, which makes the wet surface. So it seems now I have created my wet surfaces. So it says like 414 wet surfaces have been found. So I want to create a section view so that we can clearly see how MeshWorks have generated the wet surfaces. So for that I'm going to create a section line. I'm going to create by using the intersect method, and I'm selecting all my CAD, and I want to define my axis, which is X, and I want to pick the center, which is on the same existing line, and just say create. if you see, like all the inner lines, CAD lines have been organized into different PID, which means like it has separated all the inner surfaces, which makes it as a wet surface. And I want to show you how it is organized. So if you see, like the inner surface and the outer surface have been organized into different PID, which makes it as a wet surface. So if a user has to do this process manually, it takes a lot of time. MeshWorks helps to create it in very less time using the wet surface extraction method. So this is all about the wet surface extraction. Now I want to move on to the next demo, which is the parameterization part. So I have a fighter jet model on my screen, and I have created some parameters to improve the external airflow. So here I have created a parameter called fuselage. And it fuselage on the other side as a parameter. Fuselage with chains as a parameter. Cockpit stretch as a parameter. And also intake entry as a parameter. So these all parameters helps in improving the external aerodynamic study, so that a user can very quickly change the shape, geometry, and do a lot of optimization on the external surfaces, which saves a lot of time instead of waiting for the CAD. So this is about the parameterization part of the fighter jet. Now I want to switch gears and move on to the other demo, which is the parameterization on the electronic circuit boards. So here I have an electronic integrated circuit board model. On this I have some heat sinks for which I want to do parameterization. These heat sinks helps in heat dissipation in a faster rate. So for that I want to increase the heat sinks, and I want to make it as a parameter. So for that I have created two parameters. One is the height of the heat sink, and I have created one more parameter, which is thickness of the heat sink. So user can create this kind of parameters very easily, and which helps in studying the internal flow and thermal analysis. So I'm moving on to the next window where I have a engine model which is parameterized. I have my first parameter, which is on the nozzle, the shape change of the nozzle, which improves the performance of the internal airflow. And I have a parameter which improves increases the inner volume as a parameter, and the connecting bracket as a parameter. So a user can create all these parameters very easily, as I mentioned you in the previous demo. And if you remember the first demo, like I have created in very less time. So similarly, anybody can create this kind of parameters very quickly. Now
So before we move on to the next demo, we showed you how to do the morphing pretty much on all the different meshing scenarios. So we're going to show you some CAD morphing here, and we can do the CAD morphing in two different ways. We can take the mesh, we can take the final mesh after it's been optimized, and we can play that optimized position onto the CAD model, and we can get the CAD in that way. We can also do the morphing on the CAD directly, which is what Sridhar is going to show you right now.
So my last demo is on the CAD Morpher. So if you see, this is the CAD Morpher panel, and here I am going to review the parameters. And I have an aerofoil on my screen for which I have created a shape parameter. So a user can create a shape parameters for an aerofoil, like for a single member or two or three members at a time, or also we can do a pattern morphing. So this helps in the thermal analysis and also the flow analysis. So a user can create this kind of parameters on the CAD level itself instead of waiting for the actual designer to create it for you, which saves a lot of time. And also, like if you have an optimized model of the FE model, you can impose all the changes onto the CAD. As Ray mentioned, like all the optimized solution which you obtained from the eyesight or more frontier can be imposed on your baseline CAD to make it as a optimized CAD. This is all about CAD Morpher. Now it's over to Ray.
Thank you, Sridhar. Can you pass me the ball so I can share my screen? Okay, so here we're going to quickly summarize all the things that we showed you today. So here we're going to talk about a couple of key propositions in regards to MeshWorks. The first thing here is we can show you how we can drastically reduce time for all your CE models and workflows. We showed you how the auto parameterization basically works and how this is also a huge benefit in order to help you reduce your time in terms of coming up with an optimized design. And also, it is a very easy to use process to where you can see that there's minimal training that has to be given to where we can just basically show the engineer exactly what to pick and what percentages he wants to basically have for his upper and lower bound. And he can easily create parameters within minutes. Here, why do customers prefer MeshWorks? So basically overall, you can see a 50% to 80% time reduction in certain model aspects, and this particular aspect is going to be related to your CFD. So your model time can be greatly reduced. Also, as we said before, your rapid conversion is very, very intelligent in order to create all these automatic parameters for you. So we basically showed just the fillet area. We can do so many different types of changes into where we can create the wall thickness changes. We can basically stretch out the parts. We can do so many different types of morphing scenarios. So all those things are available to the user. And also, it helps in generating your MDO in order to help you reduce your weight savings and hopefully help get you some cost savings along with some of your weight savings. So these are basically the points that we wanted to highlight in our summary. I want to thank you all for joining, and we can open up the floor for any questions. I think you guys can type up the questions, and we can answer the questions as we see fit. Thank you so much. Okay, so we have one question. What is a pad? Elin, are you there?
Hello.
Hello, Abhidam?
Hi Ray. How are you?
Pretty good, how are you?
Good. So
Yeah.
I have a question about the animation when Sridhar was showing the first morphing. As soon as we assigned the morphing, like the value, it was showing animation on the screen. How was it happening? It's happening automatically, or?
Yeah, that's a function that we call manipulate on screen, okay? So let me pass the ball to Sridhar so he can show you that option.
Okay.
So basically, you have your traditional ways to moving the model, right? So you can see that the translation types we have resultant, individual direction, and a long normal, okay? So manipulate on screen is nothing but a very quick way in order for you to move the model. Just to make sure that, let's say for instance, if you have some interference and things like that, it's just a quick way for you to show the animation so you can move the model in real time. So now you can see it the next direction, so he can just basically click onto the screen and just basically move back and forth. And that's how the animation is happening.
So this is like it takes the lower and upper bounds that we define in the parameter, and it just animates on the screen for us to visualize, right?
Yeah, see, here we're not really creating any upper or lower bound. We're just basically just dragging the cursor onto the screen to the left and to the right.
Oh, so it's just showing us in which direction it is deforming.
That's exactly right.
Okay, the magnitude is not the actual magnitude. Okay.
Yeah, there's no magnitude here. We're just basically just dragging it in each direction.
And this is the option in the parameter definition, or is it after the morph set?
Yeah, so this is basically when you go to meshing and you go to translate.
Oh, okay.
Yeah.
It's like a one-time operation.
Yeah, you can link the morph set, and then you can move it back and forth, and you can accept it if you want. Yeah,
I mean, this is really useful. Like, it saves a lot of time for us to create and visualize. And sometimes we have to go back to the, if we want to make any changes, we have to re-import the model and repeat the process. But this looks like it saves a lot of time, even before we define the parameter. So that's interesting. And also, Ray, in like regular animation, like right now, we actually record, once we define to create a animation, we actually define the morph set parameter, and again, we actually need to define a design, and we visualize, and then we capture that, right? That's the current process we follow as of now. So I was just thinking, like, it would be a lot easier if you get the animation, because sometimes we have so many design variables, and we need to have like different values for each design variable, and we need different animations for each. So it would be easier if there is one, if we are able to get the animation with one single click. Say after we define the parameter, there itself, if we want to save the animation in GIF or like AVI, whatever format, if one simple click, it should be easier to get it. It would be very helpful.
Sure. Yeah, what we can do is we can take that as a requirement. When Sridhar and Rich is there at your location, we can take that as a requirement and see if we can get that implemented and see how difficult it will be to get into one of the later versions. Yeah,
you see what I'm saying, right? Right now it's like a very complicated process just to get one simple animation file. And I'm asked, like many people ask me this, like why is it not very simple? And they keep asking me again and again. And it's very important for us to make the presentations and even help us to show it. Maybe in the future versions, it would be very helpful if there is any single click, very simpler way to get the animations. Sure.
Yeah, we'll take these requirements and we'll see if we can implement these and then give you an update on it. Like I said, one of the guys come, you can tell them all the things that you would like to see, for the animation panel, and we'll try to go from there.
Yeah, even MeshWorks and even in CAD Morpher, in both places it would be helpful. And another thing I wanted to ask you is like the fillet radius parameter. Earlier, we had to define the tracking edge or the 1D boundary for it and then reorganize the fillet elements. And right now, I think it's like a lot simpler, right? We just need to select the fillet surface and all the elements in that fillet will be selected, right? Is that correct?
Yeah, that's correct. Yeah, you simply just select the CAD surface, and it does everything for you automatically in the background.
Yeah. So does it select the elements by any feature angle of that fillet face, or is it by the like the bounding surfaces of that CAD? How does it select the elements in that option?
So basically, can you show your screen once more, Sridhar? So basically here, what it's doing is, you're selecting. I'll share your screen. Yeah. You're selecting the CAD surface directly. Okay. So it doesn't care if you select the fillet surface or if you select the planar surface or something like that. You're basically just only selecting whatever surface that you want, and you're telling the software what kind of change that you want is more important. So for that particular situation, yeah, we only selected just those fillets in that area to where we wanted to optimize. So then we go to the fillet radius change function, and then that's where it's automatically going to do the morphing on a percentage base.
So that's, and like in his demo, he showed -20 to +20. That's like the percentage change, or?
That's percentage. That's correct.
Do we have even the absolute change option, like where the current radius is, for example, it's 5? Can I change it to 3 and 7?
Yeah. See, someone else also asked us about that methodology, but when you look at a fillet, in this particular region, you have like a uniform fillet. See, when you have a fillet that's converging to like a smaller size or something like that, then that's not going to help you out any. So this is why we implemented the percentage change approach, because you need to change it for a percentage, because truly in the CAD domain, your fillets are going to change drastically. They're going to converge in certain regions. They're going to form into different fillets in certain regions. So it needs to be based off. Yeah, it needs to be based off a percentage.
So it may not be, the radius may not be uniform throughout the fillet. That's why percentage is. Oh, okay, I see the point. Okay.
Yeah.
But yeah, and I think even this one saves a lot of time. It's easier, right, with less clicks, and we don't have to organize, and it will directly create the new elements in a new PID. Like, that's very.
Yeah, those days are gone. We're really trying to eliminate some of the morphing and all those different things for you guys, because like I said, we want those things to be done in the background to make it really, really easy and simple to use the tool, because we want you guys to focus more on the optimization side of things, where you're creating many parameters and you're trying to get an optimized model.
Right, because they want it to, with very less number of clicks and as simple as possible. So for some new users, that will be, very useful. And yeah, one more thing, in my previous query about the animation, it would be, if it would be better if we are able to vary the frame rate in the same panel itself, like where I asked you for an option to save the animation, right? There itself, if there is an option to vary the frame rate, because frame rate is easier to understand. Sometimes in visualization panel, there is some number I don't understand the significance of it. Like there is some number, and I know that it's related to the speed, but when you call it frame rate, it's a lot easier for people to, understand. Like if, based on increments, if I want to see the deformation happening very quickly, then I'll increase the frame rate. So. Sure.
Yeah, for all those details, like I said, instead of us discussing it here, my guys can come to you, and we can take notes of all those different details that you want to see in the upcoming releases.
Yeah. And where can we access the recorded versions of these webinars? Can we access the recorded versions on DEP's website somewhere?
Yes, we can.
Can
do you have that information?
Yeah, Ray. Actually, the webinars of the past 2 series are already there in the webinar pages of DEP website. The next 2 will be coming up shortly.
Okay. So the first 2 are available, and I see that this is the 4th one. Was there any 3rd one? Because I remember I attended only 2 before.
Yeah, there is a 3rd one. Yeah, the video is yet to come up on the website. It will be coming up shortly.
Oh, okay. All right. Thank you, Ray.
Sure.
Thank you, Sridhar.
Is there any more questions from anyone else? We'll wait another minute or so. If not, then we'll go ahead and conclude the questions. We'll go ahead and conclude for the webinar. So we again want to thank you all for joining. Thank you, Sridhar. Thank you, Elin, for our fourth webinar session. Looks like we can go ahead and conclude. Thank you all for joining. We'll see you for the next webinar.
Thanks, Ray. Thank you all.
Okay, so here we're going to quickly summarize all the things that we showed you today. So here we want to talk about a couple of key propositions in regards to MeshWorks. The first thing here is we can show you how we can drastically reduce time for all your CE models and workflows. We showed you how the auto parameterization basically works and how this is also a huge benefit in order to help you reduce your time in terms of coming up with an optimized design. And also, it is a very easy to use process to where you can see that there's minimal training that has to be given to where we can just basically show the engineer exactly what to pick and what percentages he wants to basically have for his upper and lower bound. And he can easily create parameters within minutes. Here, why do customers prefer MeshWorks? So basically, overall, you can see a 50% to 80% time reduction in certain model aspects, and this particular aspect is going to be related to your CFD. So your model time can be greatly reduced. Also, as we said before, your rapid conversion is very, very intelligent in order to create all these automatic parameters for you. So we basically showed just the fillet area. We can do so many different types of changes into where we can create the wall thickness changes. We can basically stretch out the parts. We can do so many different types of morphing scenarios. So all those things are available to the user. And also, it helps in generating your MDO in order to help you reduce your weight savings and hopefully help get you some cost savings along with some of your weight savings. So these are basically the points that we wanted to highlight in our summary. I want to thank you all for joining, and we can open up the floor for any questions. I think you guys can type up the questions, and we can answer the questions as we see fit. Thank you so much. Okay, so we have one question. What is a pad? Elin, are you there?
Hello.
Hello, Abhidam?
Hi, Ray. How are you?
Pretty good, how are you?
Good, good. So
Yeah.
I have a question about the animation. When Sridhar was showing the first morphing, as soon as we assigned the morphing, like the value, it was showing animation on the screen. How was it happening? It's happening automatically, or?
Yeah, that's a function that we call manipulate on screen. Okay, so let me pass the ball to Sridhar so he can show you that option.
Okay.
So basically, you have your traditional ways to moving the model, right? So you can see that the translation types we have resultant, individual direction, and a long normal, okay? So manipulate on screen is nothing but a very quick way in order for you to move the model. Is there any more questions from anyone else? We'll wait another minute or so. If not, then we'll go ahead and conclude the questions. We'll go ahead and conclude for the webinar. So we again want to thank you all for joining. Thank you, Sridhar. Thank you, Elin, for our fourth webinar session. Looks like we can go ahead and conclude. Thank you all for joining. We'll see you for the next webinar.
Thanks, Ray. Thank you all.